Imagine that one of these centuries we make contact with an alien civilization. It's a big cosmos with quintillions of planets, so it's bound to happen at some point. But how the heck are we going to understand what they're saying? How are we going to decode their language? After all, they might not communicate with air compression waves. Maybe they do something visual, but in ranges of light we can't even pick up with our eyes. We won't have a Rosetta Stone. So how are we going to decipher what they are trying to say to us? And this might seem speculative, but what I want to draw our attention to is that we currently are in the same position right now, right here at home, which is that we can't tell what a single one of the 2 million species on our planet are saying. Not even the 6,600 species of mammals, which are presumably kind of like us. We're not having conversations with anyone but ourselves. With all these species, I'm willing to bet you don't listen to a single podcast not made by a human. But today, we're going to see some hope, some pathways for how we might get to animal translation, and relatively soon. Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and an author at Stanford. And in these episodes, I examine the intersection of science and our lives. And today, we're going to talk about understanding animals. When I was a kid, I saw some episodes of Star Trek, the original one with Kirk and Spock. And the thing that always struck me was how every week on schedule, they discovered new alien civilizations, which is not so crazy given that the universe is presumably teeming with life. There are about 100 billion galaxies, and each of these has about 100 billion stars. And most stars have some planets rolling around them. So it's extraordinarily unlikely that we are the only planet with life on it. But before I get into alien communication, let's quickly address something first. You've probably heard of the Fermi paradox. And if you haven't, it's a very important question. It's the question of why, if there's all this life in the cosmos, why have we not heard a peep from anyone? This paradox is named after the physicist Enrico Fermi, who raised this question. If there are so many potential alien civilizations, why haven't we detected any signals or encountered any of them yet? We're living in a moment of history where there seems to be this very strange contradiction between the high probability of extraterrestrial civilizations and the lack of any shred of evidence for them. So over the decades, people have proposed all kinds of possible explanations for the Fermi paradox. The first is that maybe aliens don't exist, which is the simplest explanation, but presumably not terribly likely given the size of the cosmos. So some people point out that maybe the problem just has to do with the enormous distances, the vastness of space, and the limitations of our current technology. That might make it hard to detect other civilizations, even if they exist, because the distances between stars are enormous and signals may take thousands or millions of years to reach us. Okay, so that's a possibility. Or a related idea is what's called the rare Earth hypothesis, which is that Earth-like planets, which are capable of supporting complex life, are exceedingly uncommon in the universe. And that makes the emergence of intelligent civilizations a rare event. But again, given that there are something like 70 quintillion planets, that's a 7 followed by 19 zeros, Earth-like planets can't be too rare. So another idea is the technological singularity idea. Some thinkers have proposed that advanced civilizations might always end up reaching a technological singularity when their technology suddenly accelerates rapidly. And one possible outcome of this is that these civilizations tend to self-destruct. And a related hypothesis is that when other civilizations hit this singularity, This leads them to a post-biological existence. They're no longer products of nature, but instead they build themselves into other sorts of devices, which would be hard for us to detect given the ways that we're searching. And other people suggest that advanced civilizations intentionally avoid broadcasting their signals or their presence for fear of attracting unwanted attention or causing conflicts with less advanced civilizations. Or maybe they're just not interested in contacting us. They might be too busy with their own problems, or they simply don't see us as an interesting threat or ally, so there's no reason to pick up the phone. And then there's the possibility that they use extremely different communication methods than we do. So different that we can't currently understand them or even know what we should be looking for. So ultimately, we don't know why we haven't heard from anyone yet. There may be other reasons, or maybe multiple of the reasons I mentioned are all at play. But for now, we just have to live with the fact that we haven't yet heard from anyone. So this was part of the appeal of Star Trek. Every week they're space warping off to some new coordinates, and everywhere they go, they meet new civilizations. Now, the thing that always struck me as funny, and the point of this episode, is that each week they end up meeting these new aliens, and often these aliens look like a female movie star in a cool jumpsuit, but with subtle differences like pointy ears and green skin. But the key thing is that all these aliens speak English. Usually it's a slightly broken English with a difficult to discern accent, but nonetheless pretty easily understandable, which is of course very lucky for these star voyagers who happen in several hundred years from now to speak English themselves. Now, why did the writers of Star Trek choose to make everyone speak just like we do? Well, this is a basic constraint of storytelling. It's the only thing that will work for telling a narrative that people will tune into. It's hard to tell a story if the alien is some kind of weird fungus thing that doesn't speak or lives at a different time scale than we do, like a tree. If we land on a planet of mute, slow fungus creatures, it's not going to make good television. So the stories we tell will always have aliens that we can talk with and that serve as not so distant reflections of ourselves. Okay, so no problem. That's what storytelling requires. But in real life, it's much more likely that we're going to have a very, very difficult time communicating much of anything to aliens when we find them. You might think that we can get by with something like, take me to your leader, or some sort of hand signals. But in fact, none of that's going to work. Now, what's the reason that I say this? Why should we think that communication is going to be so difficult? Well, the aliens we find on other planets are going to have a totally different evolutionary history. They may not be based on DNA like all earthly creatures are, but instead may have found a completely different way of encoding information and managing replication and building societies. And it's possible they won't even be carbon-based like all creatures on Earth are, but instead based on something like the element silicon, which also has a tetrahedral structure and can make lots of useful elements and so on. So there's a whole field of this called astrobiology, where astro refers to star, and often known as exobiology, where exo means outside. And the idea with this area of study is to search for naturally evolved life in the universe, mostly on other planets in the habitable zone. That's the Goldilocks zone of planets who rotate at just the right distance from their star, so it's not too hot, not too cold. I'll also mention there's a closely related field called xenobiology, which means alien or foreign biology. And that term is usually reserved to refer to biology that is synthetic, not found in nature, that science has no clue about yet. The general idea is that astrobiologists try to detect and eventually analyze life elsewhere in the universe, while xenobiologists will attempt to design forms of life with a totally different biochemistry or different genetic code than on planet Earth. Now, when we search for life in the universe, I don't really see any reason to imagine a distinction between naturally evolved life on other planets and synthetic forms of life, because a planet 10,000 years ahead of us would be well on its way to building other species in the same way that our species' existence might simply serve as the spark to build an artificial species that colonizes the solar system. And so for this reason, we should always be thinking about new biologies, new animals that could use a completely different kind of biochemistry. On this planet, all we've ever seen for coding information is DNA and RNA. We have 20 amino acids from which we build all our proteins, which are like little molecular machines. But instead of DNA, we might find elsewhere what we'll call XNA, xenonucleic acid. You might find a massively expanded genetic code that uses other amino acids to build totally new kinds of proteins. Or perhaps most likely, you could have something that's not like our genetic code at all. Something to consider is that we only discovered the genetic code in 1953, which is not that long ago. I actually worked with Francis Crick, the co-discoverer of the structure of DNA. So this is massively recent, and we don't know what we haven't thought of yet. So for this reason, I think of the whole endeavor of space biology as xenobiology, thinking about and looking for ways that life could be built that we haven't yet imagined yet. And by the way, it's thought exercises like this that make me wish I could see the textbooks that our descendants will read 500 years from now or 1,000 years from now. There's going to be so much known that we currently can't imagine. That's totally in our dark zone. Things we haven't even realized that we don't know. Okay, so all of this is to say, life might be massively different than what we have here on Earth. And the question is, will we figure out how to be like Captain Kirk and beam onto their planet and have a conversation with them? Now, maybe all this talk about extraterrestrials seems abstract because we haven't discovered any yet. But I want to point out that we are surrounded by aliens. They are all around us and they're making constant sounds. We have measured this alien language with our recorders, and at the moment we have no idea what they're saying. Now, that's the sound of whales on our planet, and lots of animals make noises. And the question is, are these animals that we're surrounded with speaking a language? These are the aliens that we don't have to travel very far to listen to. And the question is, can we understand them? So, maybe not. After all, these sounds could be like belches or like grunting the way you do when you're home alone and you banged your knee the night before and you're going up the stairs and you make a sound, but it's not really meant for anyone in particular. It's just a noise that you're making. So how would we know if animals are actually implementing language and communicating meaning to one another? Well, this is an unanswered question right now, and it probably differs species by species. One thing biologists look at to try to address this is things like turn taking. Does one animal make some sound and then the other animal goes and then the first one again and then the second? That feels more like language, right? Something gets said, there's some response. It feels like there's at least the possibility for some real meaningful conversations that way. But there are a lot of questions here. Even if we found that some species were speaking language, would we be able to understand the meaning? And I don't mean this in terms of this call means this thing, but in terms of what does that thing mean for a human? Imagine if a bee is talking about some experience that you really have to see in ultraviolet to understand, or your dog is experiencing something about smell that we couldn't possibly get from our experience. Or a dolphin is talking about the joy of that moment where there's no more little fish, and so the whole pod suddenly turns upward and rockets through their world and breaks through some surface where everything is different. Might it be the case that there's simply no way we could totally understand what they mean. There may be things we can identify that they are talking about, but I think there's a spectrum of how close we would actually be in our interpretation. And by the way, I'll just note this is true with our fellow humans as well. Someone might tell you about an experience with hang gliding or stamp collecting or psychedelic drugs or whatever. And even though you nod and you say, oh, I got you, I can relate that to my own experience, there's a spectrum of how closely you're actually capturing what they are describing. Sometimes you might have an analogous experience that puts you close, and sometimes your assumptions may be pretty distant. So back to animals, how much could we even understand in a translation given that animals have such different sensory windows on the world? And so their concepts might be very different from ours. Now, even with all these caveats, how amazing would it be if we could get even a low-dimensional, blurry glimpse of what they were talking about? People have always wanted to understand animals, and they've tried in the past, but we are at an amazing moment in history where I think the time is right around the corner. And I'm not saying this as a general claim, I'm saying this for two specific reasons. First, we have incredible technology now, which makes it possible to do biologging. What is biologging? This is about collecting data from an animal with a small, lightweight device. These are called biologgers. You hook these up to an animal, and that way you can collect data for long windows of time without humans being around. You can record sounds and measure physiology and track movements. And this is how you get a secret window into an animal's world. The key thing is that it gives new, rich data that you just can't get otherwise about animals in their natural environment. Now, it's not always easy to attach the biologgers to animals, especially if they're small and fast. But the main problem is that the data collected by the biologgers can be really complicated and difficult to analyze. So we humans have amassed a ton of rich data that we're sitting on, and that leads to the second specific reason why we're just on the verge of something amazing. And that's artificial intelligence. AI has been used for years to translate and decode human languages, and now we have this incredible opportunity to leverage it for understanding animal communication. And I'm lucky enough to be friends with one of the people at the lead of the effort to decrypt these alien languages that we're surrounded with. So how does our modern technology give us hope for decoding animal language?
So the insight originally came in 2013 when I was listening actually to NPR, and there was a researcher describing gelada monkeys.
That's Aza Raskin. He's a writer, an entrepreneur, an inventor. And for the purposes of today, he founded the Earth Species Project, ESP, which is a nonprofit focused on using AI to decode non-human communication.
And these animals they're incredible. They live in the Ethiopian highlands. They have like huge manes, red patches on their chests. And what I didn't realize is that, according to the researcher, they had one of the largest vocabularies of any primate except for us humans. In fact, the researchers swear that these animals talk about them behind their back. And so the thought back then was like, well, if people are just out there, the researchers are just out there trying to understand what these beings are saying using like a hand recorder and hand transcribing, couldn't there be a better way? Couldn't we use like machine learning, AI, large scale microphone arrays? But of course, in 2017, that wasn't yet possible because machine learning couldn't do something that human beings couldn't already do. They couldn't translate a language without a Rosetta Stone, without any examples. And that really changed in 2017 when the machine learning community, there were two papers that came out back to back in the way this thing happens that showed that you could translate between any two human languages without the need for examples or Rosetta Stones. And I can dive into how that works, but that was the moment that we said, we should get going. And along the journey, I just should say, like, all right, is there even a there? Like, we say animal language. What does that mean? What is a rich, complex communication structure? What would that look like? I just want to give a couple examples for your listeners. So off the coast of Norway every year, there's a group of false killer whales that all phenomenologically speak one way, and a group of dolphins that all speak another way. And they come together and they hunt in a superpod. And when they do this, they speak a third different way, which is just sort of crazy, right? Like, and it turns out that whales, have a culture extending back 34 million years. They have dialects that sort of split off, which they can't understand each other with, and that can split all the way into mutually unintelligible languages. Another example is, I learned this in 2014, that for Campbell monkeys, hawk for them means eagle, crack means leopard, and hawk-oo means predator that's up. Crack-oo means predator that's down. So now we have a simple syntax. And then one of my favorite studies is from the University of Hawaii in 1994. And here they taught dolphins two gestures. And the first gesture was, do something you've never done before, which is sort of a crazy thing to be able to communicate, but the dolphins would do it. And to remember, to do that means they have to remember every single thing they've done before that session, understand the concept of negation, not one of those things, then invent whole cloth, some new thing that they've never done before, but they can do it. And then they'll teach the dolphins a second gesture, do something you haven't done before together. And they'll say, at the same time, do something you haven't done before. Together, the dolphins go down, exchange sonic information, come up and do the same trick they've never done before at the same time. And while that doesn't prove representational language, it certainly places, I think, Occam's razor on the other foot.
It certainly seems that way. How do you know, though, when you're approaching these, that there exist languages? For example, you said that whale culture or civilization is 34 million years old. But how do we know that they're speaking a language that has the kind of structure that we have that is capable of passing on a culture or civilization?
Yeah, great question. And of course, it's hard if you can't listen in and understand. But, there are two hallmarks of language that human beings have, one of which is to be able to talk about something that isn't here and something that isn't now. Can you refer to things that are in a different time and a different place? And we can actually see already from the research that the answer is, it appears to be the case that at least some animals can do this. So Adrian Lumero is a researcher on great apes, and he's discovered in the last year or so that orangutans do have a version of a past tense. They can talk about things that are not now. And then dolphins have names that they call each other by. And Ian Yannick in 2016 discovered that they will use those names in the third person. They can talk about one of their own that is not here. So now we have two of the hallmarks, not here, not now. Now, when we say language, we only have one example of a species that speaks what we call language, humans. And almost always, like if you only know one color and then you learn a second color, you discover an entire rainbow in between. Like when we say language, we're using that to be a catch-all for rich communication systems that can pass on cultural information.
Yeah, agreed. Let me jump back to the orangutans for 1 second. Is there any evidence that they have future tense?
That's a great question. We do not know. And that's what's so exciting about this field right now is I think of this, it's sort of like the invention of the Hubble telescope. Right? It's like, and if you remember, I think it was back in 1995, they pointed the Hubble telescope at an empty patch in sky. And what they discovered was the most galaxies that have ever existed in one spot. That's essentially what we're discovering here, is that we just haven't had the tools to look. And when we do, what we're discovering is much more than everything we discovered. What we're discovering is everything.
Yeah, exactly right. The deep field experiment. So how do we actually do it? How do we apply all the modern tools of science to see if we can decode a language?
Yeah, great question. So I'm going to start with this 2017 technology. And I just want your audience to remember that 2017 is essentially the Stone Age in AI. But I think it's a really useful conceptual tool to understand how it might work. So how do you translate between languages that don't have Rosetta Stones? And it turns out what you can ask AI to do is build a shape that represents a language. So you say, feed in all of Wikipedia, a whole bunch of text, and the AI generates a shape that represents a language. Imagine a galaxy where every star is a word, and words that mean similar things are placed near each other. And then words that share a sort of conceptual relationship get turned into sharing a geometric relationship. What does that mean? That means, if you imagine king is to man as woman is to queen, then in this shape, king is the same distance direction to man as woman is to queen. And so you can actually just subtract king minus man. That gives you a distance of direction. You add that to boy, and that'll equal prince. You add that to girl, it'll equal princess. You add that to woman, it'll equal queen. And so if you think about all of the relationships, the internal relationships of a language, so think about the word dog. Dog has relationship to man and to howl and to wolf and to fur. It sort of fixes in a point in space. And if you solve this massive multidimensional Sudoku puzzle of how every concept relates to every other concept, that gets turned into a geometry, and out pops a rigid structure that represents a language. Now, the computer doesn't know what anything it means. It just knows how they all relate to each other. The shape represents all of the internal relationships of a language, which is, of course, just a model of the world. All right. So you have this shape for English, and this is what the machine learners asked in 2017. Is it possible, they said, that the shape which is English might be similar to or the same as the shape which is German? And if you asked anthropologists, they'd be like, no, that's a silly thing to think. Like, they have different ways of viewing the world, different cosmologies, but the machine was like, whatever, let's give it a try. And it turns out that it works. You can take the shape which is English and the shape which is German and literally rotate one shape on top of the other. And even though there are words in one language that don't appear in the other, if you blur your eyes, the shapes are roughly the same. And the point which is dog ends up in the same in both. Now, you might be saying, okay, but that's because English and German are very similar languages. But it turns out this works for Finnish, which is a really weird language, Turkish, Aramaic, Urdu. Pretty much every human language fits in a kind of universal human meaning shape. And the point which is dog ends up in the same spot in all of them. And this lets you do translation without the need for any examples. And this is, I think, such a beautiful, profound realization that there is a hidden structure underlying all of us that unites our way of seeing. So that was the sort of the core insight that said, well, maybe now it's time to start building that shape for animal communication, which, by the way, is very hard because it takes denoising and working with many partners to collect like the year's worth of data that's required. But that's sort of what we started to do. Now, I'll pause for a second, but there are a couple other techniques that can add to the top of this.
Great. So let me jump in for 1 second. So the fact that all the human languages have a similar structure to them is in part because humans radiated out of Africa sort of yesterday. And as a result, we all have the same brain, and it's not so surprising. And the question is, what do we expect when we're looking at animal languages, which I'll come back to some more questions on that in a second, but what do we expect in terms of the similarity there? Given that animals are picking up on different signals from the world, their umwelt is different, the signals they can get, and their concepts might be very different. How do you think about that?
This is a great question. It's just to repeat what you're saying is that the sensorium, the way that animals perceive the world, like what it is like to be a bat, may be so completely different than what it is like to be a human because they're seeing in 3D sound that we can never translate anything. And that may turn out to be the case. But, I think there's reason to believe that there may be some kind of overlap with our experience. And to just give a couple examples, lemurs, for example, are known to bite down on centipedes, literally to take a hit off of centipedes to get high. They enter this very trance-like state. They get super cuddly. It looks sort of like a scene from Burning Man. Dolphins, too, are known to intentionally inflate pufferfish to get high off of their venom and then pass them around, literally puff, puff, pass. Great apes are known to like hang off of vines and spin to get dizzy. There is something about a transcendent state of consciousness altering our state that is at least shared amongst the mammals. And so if they're communicating, they may well communicate about that. And that's something we'd share. Another example is something known as the mirror test. This is a test where you take an animal, you paint a dot on them where they can't see it, you give them a mirror, they look in the mirror, they see the dot, and they turn to the dot and they try to brush it off of themselves or investigate it. And in order for an animal to do that, they have to associate the image that's in the mirror with themselves. They have to look in the mirror and say, like, that's me. So that means there's a rich sense of interiority, like a self-awareness. Dolphins pass this test. Elephants pass this test. A number of other species pass this test. So even the concept so profound as me self-awareness, that seems to be shared. You know, examples of people showing orangutans magic tricks, and they go crazy. It's worth just looking them up on YouTube to see these kinds of videos. Pilot whales carry their dead young for 3-4 weeks. Like, grief is a shared part of the experience. So if you imagine these shapes, where one of the shapes is like human languages, one of these is animal communication, I think we should expect to see some part of those shapes overlap. And that should be the part we should do direct translation. But then there's going to be a huge portion of the shape that can never be directly translated to human experience. And you'd sort of expect that to be sticking out, like where we can see complexity, but we don't know how to translate it. And I still don't know which one of these two is going to be more fascinating. The part where we can directly translate, or the part we don't, because as I was saying, human beings have been communicating vocally for 100,000 to 300,000 years, passing on culture. Whales and dolphins have been doing this for 34 million years, and that which is oldest correlates with that which is wisest. So for something to survive 34 million years, there has to be some deep kernel of adaptive truth in there. And whatever it is that is the solution to humanity's problems, like, it's not in our imagination, because if it is, we'd probably be trying to do it. So this is a way of starting to get the first Polaroid sort of blurry image pictures of that which is beyond our imagination.
Now, let me ask you this. If we're just looking at the auditory information that we get from animals, we can do this kind of technique where we're looking to match one galaxy of stars to the other galaxy of stars and see what parts are sticking out and so on. But we may well need much more than just the audio, right? To understand the context of what the animal is saying in a particular situation. So how are people pursuing that?
That's a great question. Even for humans, we know that so much of the information that we convey, if you've ever had to try to order food in a country where you don't speak the language and somehow you can do it, you can have communication without words. The same thing may be true for animals. So in fact, chimpanzees are known to have 60 plus hand and feet gestures, which seems to be, at least as far as we know, their predominant form of more symbolic communication.
Plus, we have indefinite references to things all the time, right? So when I say she, I might be talking about Marie Curie, or I might be talking about Michelle Obama or something. But once I've introduced who I'm talking about, I can just use the word she. But somebody trying to decode what I'm saying, who doesn't speak English, might have a hard time understanding what the reference is to.
Yeah, that's exactly right. And what you're speaking to is the importance of context. In order to understand what someone is saying or what an animal is meaning, we have to understand the context. Otherwise, like, the same grunt may mean like that monkey, or it may mean like I'm upset. And it all sort of depends on social context. So a lot of what we do now is multimodal. That is to say, we work with biologists that have tags on animals that record often video, audio, and motion. And that lets us begin to translate between all of these different modalities. And in fact, with some of the species we work with, these tags are on multiple animals in the same group, so we can get social context. And I want to return for a second to this really interesting question you posed. You're like, well, maybe all human languages fit in the same shape because we share the same physical substrate, the same brains and the same ears and the same eyes. But there's something deeper going on in machine learning than just the ability to match the shapes of languages. Maybe your audiences heard of or seen Dolly or Midjourney or image diffusion, where you type in text and out comes an image that has never been seen before. How does that work? Well, these shapes are actually really helpful to have in your mind to understand how it works. So let's build now a shape on human faces. And once again, you end up with a galaxy where every star now isn't a word, but is a human face. Faces that share similar relationships, share geometric relationships. So if I take a picture of your face, David, and I take a picture of your face that's smiling, there's this distance and direction that takes me between your face and your face was just smiling. I subtract those two as I get smilingness. As a relationship, I can now add that to any other face in the shape, and I'll get the smiling version of that shape, of that face. Right? So now there's a direction that represents smiling. There's a direction that represents frowning, that represents age, that represents gender, more male, more female. You end up with a map of all the semantic relationships. And you can now take that, you do that not just for faces, you can do that for all of images. And now you have a shape that represents images, a shape that represents languages. You look at image caption pairs on the internet, and you can align these two shapes. So now you have a way of translating between text, language, and images. So now you just type in something like image, like portrait of the country Chile as a woman. It goes into the language space, gets translated to the image space. The computer generates the image that's there, and you get that. So that's how that technology works. There's something really deep actually happening, because it's not just working on language. It seems to work on almost any modality out there. And I think just like there is the unreasonable effectiveness of mathematics, where it seems very strange. You go out on some branch of abstract mathematics that seems like it has nothing to do with the world, and then it has something profound to say about the world. You invent complex numbers. Somehow that describes everything you're going to need to deal with electricity. Who knew? That's going on in deep learning, where there's an unreasonable effectiveness of deep learning, where the same techniques are working across every modality, from DNA to fMRIs to language to audio to video to images to computer code. There's nothing that says that had to have worked, and yet it seems to be working. So we're learning something, I think, profound about the structure of our universe. But what that means for us specifically is that means we can build these kinds of shapes and embed and translate between how an animal behaves and how it sounds and what its body pose is. So we can say, we're not quite there yet, but we're moving towards it. Generate me the audio of two elephants coming together. And that's going to give you a distribution of calls, some of which might mean like hello, some of which might mean this is my name, some of which might mean I've missed you. You don't know, but it has something to do with affiliation. Then you say, okay, now generate me the audio of two elephants coming together, but where one of them's flapping its ears and the other one's running quickly. What kind of sounds does that make? And you can see that this becomes a laboratory that lets you very quickly iterate to understand what animals are saying when you get to do this in combination with the incredible biologists that are out in the field and have already built up a lot of that context from time, blood, sweat, and tears.
Excellent. And I think the biologging is becoming more sophisticated even, right? Where they're looking at temperature and weather patterns and gyroscopes and accelerometers and so on, where you get all of this data from the animals. And in theory, there's no limit to how much we can biolog as long as we can make it small and portable and get that on the animals. And then we're able to discover, hey, these are the contextual cues that the animal is responding to with the language.
Yeah, that's exactly right. And in fact, a big shift that's happened in biology and conservation and ethology in the last, 4 or 5 years is because of cell phones driving the cost of sensors lower. Biologists have gone from a world where they're often data starved to where they're data drowned, where they have access to terabytes of data, but they don't yet have the tools to understand them. And so, our goal is to decode non-human communication, translate animal language, and use that to transform our relationship with the rest of nature. But it's sort of like you're trying to go to the moon. Along the way, you invent Velcro. We're building the foundational tools that every biologist needs to understand the data that they have now. And our hope is that by building those foundational tools, we're a nonprofit, we're open source. we try to give back as much as we can, that can broad scale accelerate all of like conservation science, which we hope can also accelerate conservation itself.
Now, I have a technical question, which is, if you are looking at human languages and making this high dimensional space of all the words, when you're listening, when you're eavesdropping on whales or lemurs or whatever species, how do you know what a word is, what a unit of meaning is?
Yeah, a hard problem, and there's no one easy solution. But one of the things that we can ask the AI to do is try chopping up the audio in many, many, many different ways, and then see which one of those ends up making good predictions for what comes next. And so you can see if you're trying and varying and you're not saying, well, which thing contains meaning, but which things help make good predictions. You know, when you try this on humans, you end up with phonemes that you get out. And then those are then combinatorially built into words. So we're playing with those kinds of techniques, but we don't have like one surefire way yet.
And when you're thinking about predictions, one of the ways that you could test a prediction is with playback, right? So tell us about that.
Yeah. So this is the classic way that you test your predictions in the field, where biologists go out and they will play a sound, often from the animal, and they'll see whether the animal looks and for how long. What we are starting to be able to do is, just like you can build a chatbot in text that speaks Chinese without needing to speak Chinese, we are on the cusp of being able to build these kinds of chatbots, but that just directly speak in the language of animals. So it's sort of like, imagine you had a superpower, and your superpower was to go out, meet someone whose language you don't understand. You sort of cock your head to the side and you listen for a little bit, and you're like, I don't know what anything means, but I see that this sound pattern follows this sound pattern in this context. And you just start to babble. And you have no idea what you're saying, but the other person's like crosses their arm like, yeah, wow, that's so meaningful. And at the end, the person walks away thinking they've had a great conversation. You're like, I have no idea what I just said. I was just babbling. But that's literally what ChatGPT does. And that's the kind of thing that we are going to be able to build in the next, 12 months. And what does that mean?
Just so it's clear, can you give an example of playback and the kind of things that people are doing right now with that?
Yeah. So an example of a playback might be one of our partners, Michelle Fournet. You can your listeners can go watch her incredible documentary, Fathom. She was trying to determine, how do you say hello to a humpback whale, and possibly include their name. So to say hello in humpback, it turns out, is something like whoop. And to test this, she recorded many different, they're called whoop calls, but they're hellos, many different whoop calls, and then went out to Alaska, set up speakers underwater, and would play the hellos in a very controlled condition and would see, do the humpbacks respond? And the answer is yes. Yes, they do. When she said hello, they would respond in greater number of saying hello back. So that's an example of a playback experiment.
And I know you've thought a lot about the ethics involved in this. So far, what we've been talking about sounds amazing. And the question is, what are the ethical things that we need to keep an eye on?
Yeah, that is a great question, because we are going to be crossing this barrier very, very soon, which is this is the plot twist, that we will be able to communicate before we fully understand what we're saying. Like, that's, again, very surprising. I would have not have guessed this if we rewound the clock 3 or 4 years. What does this mean? This means that if you're working with a species which has vocal learning, well, you might inject something that they say that then changes their culture. So to give an example, humpback whales off the coast of Australia, for whatever reason, the Australian humpbacks seem to be like the K-pop singers. And because they can sing halfway across an ocean basin and they migrate across the world, often the songs that are sung off the coast of Australia will catch on and be sung by much of the world population within a couple of seasons. So it's, the ultimate pop tune. Now, we don't know as humans what truly the function of humpback whale song is and how that culture works. So if we just create a synthetic whale that sings, we may infect a 34 million year old wisdom tradition, create some kind of viral meme, a whale QAnon. We just don't know. So we have to be very careful as we approach this new responsibility of what does it mean to truly communicate with the other cultures of Earth. And that means we should not go out and start playing like two-way communication real time. We should not do those kinds of experiments with wild populations that vocally learn. We have to think about what is it to have like a prime directive, a Geneva Convention for cross-species communication. And this is, of course, terrifying. And I should say everything that our species does, we do with biology partners and institutions. We are starting to work on what are the ground rules before we even have the technology for knowing when and how it is okay to have these, prime directive first contact moments, because first contacts have often not gone well for the beings being first contacted. So I think the change in the relationship for how we relate to nature is the point of Earth species. And it's exciting that we're getting to the place where like that becomes a necessity.
And what's your prediction for how long it'll be? What year will have a meaningful conversation back and forth with the species?
Wow.
Which do you think will be the first species?
Yeah. This is science, so it's always very hard to make predictions like this. And different people on my team have different predictions. So I can just say mine, but know that answers vary. I think certainly by 2030, we will have had two-way back and forth. To what degree we understand, unknown. But I think we will have a really good handle on it by then. It's so exciting. My personal favorite is belugas. Again, everyone has their own personal favorite, but when you listen to belugas communicate, it sounds like an alien modem. It sounds digital. There are lots of whistles in there. It turns out that, dolphins, they say their name, their signature whistle in a whistle. It's like a single band. This is like full modem packet. It encodes their name. It encodes their clan identity. And Dr. Valeria Vergara, with whom we work on beluga communication, she's sort of like one of the preeminent scholars. It was her work that showed that they have names that they call each other by. And what blew my mind is that when she talks about her data, she's like, she had to throw away 97% of her data in those studies because she couldn't tell which beluga was speaking or disentangle them. And that's because there are like 40 belugas in a tight mass that are moving around super fast. It's very hard from a computational perspective, but that's where your listeners' ears should perk up, because here we have the most vocal underwater species with the largest vocabulary that we know of. And the supermajority of data, like 97%, is unknown. The ocean is 5% explored? Beluga communication, or at least this data sets, are 3% explored. Like, this is where you get like brand new discoveries. This is the next frontier.
And do belugas do turn taking, by the way, which is one of the signatures of an actual language as opposed to just broadcasting noise?
Yeah, a number of species do turn taking, from parrots to geladas to many of the whale species.
Yeah, I know this is one of the signatures that people look at to try to figure out how would we know if this is actually a language versus they're just singing songs or they're doing whatever, but they're not listening back and forth, which leads to this question about if we find alien species, eventually we find life on other planets. The question is, how much do we have to share with another species for us to have some meaningful interpretation of the language? Because fundamentally, we're trapped in our internal model, and a species that's so different, we will impose an interpretation on what they must mean by it. But I wonder, when we find an alien species, how we will ever be able to know whether we understand enough of their language to say that we have a meaningful interpretation of it.
I mean, when you say that, it just makes me wonder, how do we ever know that when we're communicating with each other as humans, that we truly understand each other? And there's almost this undeniably huge and yet invisible gulf. Like the myth of communication is that it ever happened in the first place. We never truly know. We can only have clues that we are getting closer, that we're approaching knowing. I think it's really important to call out how much of our language is built on the metaphor of bodies. Almost all of it is body and space, right? Like even the things that we might think are really abstract, like cursor on your computer. What is the root of cursor? In Latin, it's cursor, the one who runs. It's the man who runs. Impede against foot. It's like the deeper you look into language, the more you realize, and George Lakoff does an incredible job in a book called Metaphors We Live By, really deconstructing all of the ways that what we think of as our most abstract ideas can be traced back to a root of us having bodies and talking about our bodies in a physical world.
And particular bodies.
That is true.
What I mean is when we find an alien species, let's say they're more like slime mold or something, that might make it very difficult for us to understand their metaphors.
That is exactly right. And I think the hope here is that because we are conditioned on and live in a physical world, that to the extent that there is an outside world in which we share, and that will give the kind of grounding that's needed to do some kind of translation. But I think it would be wrong to say that the translations are going to look like Google Translate and you're going to get word for word English. It might end up looking like a translation is more like a piece of art or poetry, where the translation is very ambiguous, but if you spend enough time with it, you start to get a felt sense of what it's like. Or maybe you're right, and maybe it'll be so different that there's just some things we will never be able to grok.
Or right in between, we'll impose an interpretation, even though it will be incorrect.
Yeah, that is true. And at least here on Earth, there are sort of two failure modes. One is anthropomorphizing, which is what you're talking about, is assuming that we can only relate to the experience of others through our own experience. That's the only way it ever happens. It's very simple to say, but it's actually profound when you think about it. So there's a over projection of ourselves onto others. And then the other side is human exceptionalism, where we assume that our experiences are completely unique to us and we share nothing with other animals. And obviously the answer, the truth is in between the two. And then we have to have the self-honesty to understand and the way of asking questions that lets us determine when we are over-projecting.
Yes, exactly. And I'm really interested and this might not happen in our lifetimes, but when we discover completely alien life, I mean, as in living on other planets that might be so different. Maybe they don't have DNA. Maybe they have a different coding system. Maybe they have very different bodies. The question is, how much is Earth exceptionalism true? You know, in Star Trek, they go around and they communicate with all these aliens and they have a good time and, really understand each other to some degree. And the question is whether that will be the case or not.
Yeah. I mean, if you start thinking about, I think in Star Trek, they have the crystalline entity, which is a giant being the size of a whole planet. And at that point, I think I'd come a little more along your lines, that the scale at which a being of that scale, or the scale of which that being is feeling and sensing is so broad, we probably share very little. But anything of roughly our size, and if they have family structures, like then there's like hunger, there's being tired, there's safety, there's familiar relationships, there's gossip. And those things are probably conserved across many, many different types of beings.
So we're entering a really exciting time, but the challenges are real and there are still a lot of question marks. For example, in the scientific literature, there's an ongoing debate about which species might have languages. Some researchers listen to a particular species and say, that seems like that could be language. And others listen and they say, no way, that's not language because there's no turn taking. And also because the order of the sounds doesn't seem to make any difference. And these are all valid debates because we don't actually know what qualifies as a language and what doesn't. Some species, for example, some songbirds, do what's called duetting, where they're singing at the same time. Does this mean they're not doing language, or is it possible there are very different ways of doing language? I'll give you a concrete example of a different way of doing language, which is sign language. It turns out that the temporal order doesn't matter very much in sign language. You can switch up the order of the words, and it can still mean the same thing. And there are aspects of it that are spatial. So for example, in American Sign Language, you can indicate that something happened in the past by doing the signs slightly to your left. And if you make the same signs over on your right side, that means you're talking about the future. So it's the same signs with this subtly different spatial position, and it can mean different things. And I call it subtle because if someone didn't know to watch for a slight spatial change, they wouldn't even notice it. And even a language that only uses sounds can be very difficult to decode because so much of it depends on shared assumptions about meaning. So just as an example, if I'm talking about someone named Aviva, I use her name once, and in the next sentence, I just say her, and you know who I'm talking about. I'm referencing Aviva. But if you are an alien working to decode my language, you might be confused because 1 minute later, you hear me use the same utterance, her, but now I'm referring to someone else entirely. I'm now talking about Sarah, but I still use the word her. So the same word can refer to totally different things, and the alien would be very confused if it had concluded that her was the word for Aviva. And in the same way, when we hear a whale make the same sound that we always hear, it might be talking about something totally different than the last time that used that sound. The context matters. And this issue of context, in other words, what's going on around the animal, this is why biologgers are interested in collecting things beyond just the audio data. Good biologging now uses video and gyroscope and altimeter and GPS and any other measure they can get their hands on. And this matters because so much of communication is about context. And by the way, a lot of it is nonverbal. Consider how you pick up stress from someone else, even without words. Body language, the tightness of their facial muscles, the way they're walking, and so on. And animals presumably have many equivalents to this. Just think about smells and pheromones. Take a close look at your dog the next time you're on a walk. It's obvious that a lot of your dog's language is happening silently. So all this is to say that language can be complicated and much of it can be nonverbal. And this is why the challenge of decoding animal language is a big one. And one of the things that I'm always on the lookout for is whether we can see any evidence that animals engage in something like storytelling. One of the classes that I teach at Stanford is the brain and literature. And I teach how weird it is that we go to the theater or the movies or a lecture and someone speaks and whoosh, we get immediately transported into a different space and time. It's like a guided dream. I'm going to do an episode on this issue soon. But for now, I just want to point out that we don't see bears congregating, like hundreds of them on a Saturday night, listening to one bear grunt along. And I'm not certain that we see that in any species, but I don't know. But these are the kinds of clues we would look for as we move forward. These are the questions of not just do they have some simple language, but what they can do with their language. This is a tougher problem and one that we need to keep our eye on. So there are plenty of remaining question marks all around us, but what's clear is that technology like biologgers and artificial intelligence are leveling us up into a very exciting time. Not all species are going to have something interesting to say, but many might. And if we find we can decode animal language due to the labors of Aza Raskin and his co-founders Katie and Britt and dozens of other people in this exciting field of animal communication, that will give us a very different view of ourselves and our species on this planet. Our grandchildren will grow up and they'll feel amazed that we considered ourselves the only ones. And it wasn't even necessarily because of species chauvinism, but instead because we could only hear our own voices, and therefore we thought we were the only ones in the room. And with enough time, maybe we'll have enough technology and practice at decoding animal languages that eventually, in the more distant future, we can tackle extraplanetary communication. And our great-great-grandkids will be amazed that there was a time when we thought we were the only ones in the galaxy. We may be looked back upon as the era of loneliness, surrounded by voices of all types that we just didn't know how to hear. Please join me at eagleman.com/podcast for more information and links to various animal communication projects and further reading. Send me an email at podcast@eagleman.com with questions or discussion, and I'll be making an episode soon in which I address those. Until next time, I'm David Eagleman, and this is Inner Cosmos.